Hi guys, in this episode of Shri series, we're going to be talking about simultaneous equations and using substitution, but doing more questions, alright? So if you looked at my previous video, I did introduce substitution, we did 2 questions, but I thought we do more questions in order to enhance student confidence, alright? So like I said, what happens in simultaneous equations, you've got 2 pair of equations. You've got equation 1 and you've got equation 2, and you need to solve at the same time the values of x and y. Hence, it's simultaneous, all right? What do we mean by substitution? We're replacing one letter with an algebraic expression, all right? So the same example that I used before, suppose we've got y is equal to a plus x, and let's say we've got z plus y, all right, is equals to 10, and we want to work out what we using substitution to put in this equation. Literally, I'm going to put the value of y, which is a plus x, into this expression. So therefore, that's going to be z plus a plus x equals 10. All right, now we can't simplify that further because we've got unlike terms there. So this is just a rough idea on what substitution is, and we're going to be applying this concept in this question here. So I'll just rub this and then we'll go through the question right there. All right, so let's read the question. X is equal to 3x minus 5. All right, and then you've got the second equation, which is 3x plus 5x equals 11. All right, so what do we need to do? Now I can see clearly we've got the value of x, which is 3x minus 5, and I'm going to put that 3x minus 5 in place of x in my second equation. All right, so the 3x minus 5 in my first equation, which is a value of x, I'm going to substitute that and put that in my second value of x in the second equation. So what does that become? All right, so let's now simplify that. So you're going to get 3y plus 5, 3y minus 5 equals 11. All right, so what have I done? I've literally put 3y here, and I've put 5, and in place of x, I've put 3y minus 5. So what I'll do is I'll just underline that in green just to show you that 3y minus 5, which was the value of x, is actually the substituted value from the first equation. All right, what do we do from there? We're going to be expanding. We've talked about expansion, so if you're not too sure about expansion, please refer to my previous videos. All right, so what are we going to do? We're going to get 5 times 3x and 5 times negative 5. All right, so when we expand, what do we get? We get 3y plus 15y minus 25 equals 11. All right, what I'll do is I will move that equation up there and simplify that further. So I'll just rewrite that. 3y plus 15y minus 25 equals 11. All right, now what I can do here is I've got 3y and 15y as my like terms, and then I've got negative 25. What I can do is I'll move negative 25 over there, and the sign will change to be positive 25. All right, so that's going to be 3y plus 15y, by now you guys know that, which is 18y, and then you're going to get 11 plus 25, all right? So 18y equals 36, therefore y is equal to 2, all right? So, like I said before, we now need to work out the value of x. We got 2 choices. We can either put the value of 2 in the first equation, or we can put it in the second equation. All right, now like I said before, you want to put it in an equation which will be easy to solve. All right, you want to make your job easy. So between 1 and 2, I think I'm going to put the value of y in my first equation. So I'm just going to double tick so you guys can see which equation I'm going to substitute it in. All right, so I've got x is equal to 3y minus 5, and in place of y I'm going to put 2, so that's going to be x is equal to 3 times 2 minus 5, and that's going to be 1. So the value of x is equal to 1. All right, so what that means is when I put y as 2, I should get the value of x as 1. So I have students who come to me and say, am I correct? Can you please check? And I tell them, why don't you substitute? Why don't you literally put the value of y as 2 and x as 1 in both the equations to test if you're correct. So let's look at the first one. If x is equal to 1, 3 times 2, which is y, is 6. 6 minus 1 is 6 minus 5 is 1. So the value is correct. Let's see if we can put that in the second equation. Y is equal to 2. So 3 times 2 is 6 plus 5 times 1, which is the value of x. So 6 plus 5 is equal to 11. So we are correct. All right. So that's how we work out questions involving simultaneous equations using the method of substitution. All right. I'm now going to solve another question. So let's look at these two pairs of equations. All right. So I'm just going to put that as equation 1, and we're going to put that as equation 2. All right. So we've got x is equal to 4x plus 1. And 2x minus 3x is equal to negative 23, all right, as my second equation, all right? What do I need to do? Now, I can see the value of x is given here. So literally what I can do is I can put the value of x in the first equation and put it in the second equation, all right? So that's what I'm going to be doing. So I'm using the arrow to show you my point of approach. So let's use green. So you're going to get 2y, minus 3, different color, 4y plus 1 equals negative 23. So what have I done there? In place of x, I've put 4y plus 1. All right, that's literally what I've done. Then what I'm going to do is I'm going to expand. All right, so it's exactly the same process that we've done. So that's going to be 2y minus 12y minus 3 equals negative 23. All right. I'm now going to move that equation over there. So what we're going to get is, I'm just going to rewrite this, and then you can see the continuity. So 2y minus 12y now becomes negative 10y. And that's going to be negative 23 plus 3, because literally I've moved it over there and the sign is going to change. So negative 10y is equal to negative 20. Therefore, y is equal to 2. All right, so y is equal to 2. What do we do from there? We're going to put the value of y in either equation 1 or equation 2. All right. Now you want to put it in an equation that is easy to solve. So therefore, I'm just going to put it in this one here because it's easy. Makes my life easy. All right. So what I'm going to do is I'm going to put the equation x is equal to 4y plus 1. So x is equal to 4 times 2 plus 1. And therefore, that answer is 9. So what I'm going to do is y is equal to 2. So I'm going to put y is equal to 2, which I've already done. And the value of x is equal to 9. All right, so the value of x is 9 and the value of y is equal to 2. All right, so let's see if we're correct. Let's see if we will get the answer. Let's put the value of y as 2 in the first equation. 4 times 2 is 8 plus 1 is 9, so x is equal to 9. If we're still not confident, let's work it out on the second equation. Let's put y as 2, so 2 times 2 is 4, and 4 minus 3 times 9 is 27, and 4 minus 27 is negative 23. So we're correct. All right. Now, like I said in the previous video where we did similar questions, simultaneous equations, you need to understand expansion. You need to understand grouping of like and unlike terms and linear equations. If you don't understand these basic concepts, simultaneous equations is going to be hard. All right. If we go to the previous example that we did, which is here, same step. All right, you need to know how to expand. You need to know your basic processes of solving linear equations and substitution to get to the answer, because if you don't, these questions are going to be hard. All right, in my next set of videos, we're going to be solving simultaneous equations using the process of elimination. All right, thanks guys for listening. Bye now.